In this lecture, I'm going to talk about functions. So the first thing you should know is that functions are not unique to Unreal Engine. A function is a concept that comes from mathematics and computer science. And the basic definition of a function is that it is a procedure or a routine meant to carry out a specific task or series of tasks. So in computer science and programming, a function is a specific block of code. By extension, in Unreal Engine, a function is a specific node graph. So let me show you an example. I'm going to create a function that will take someone's name as input and then output a message using that name. So to create a new function, I need to go to the My Blueprint tab, look for the Functions category, and then click on the Add button. And I'm going to name this function Welcome Message. And whenever you create a new function, it will automatically open that function's node graph and add its entry node. The entry node is the node that will fire first whenever a function is called. And in the details panel for a function, you have the ability to add inputs and outputs. So for my welcome message function, I will need one input, a string variable to hold the person's name, and one output, a string variable to hold the message that I will print to the screen. So I'm going to click on the plus sign in the inputs category to create a new input variable. And I'm going to change its type to string, and I'm going to rename it to first name. And you can see by adding an input, it has created this pin on the entry node where I can retrieve that input for use in my function. So now I'm going to click on the plus sign in the outputs category to create my output variable. And I'm going to name it message. And creating an output variable will create this node here, the return node. The return node will always be the last node of a function, and it will contain pins for each of your output variables so that you can pass that data back out of the function. And note that the inputs and outputs don't have to match in either number or type like mine happened to do here. So you can make functions with any number of inputs or outputs with all different combinations of variable types. Alright, so now I'm going to add the actual logic of the function. First, I'm going to add in a pin node, which is used to combine strings together. And note that the append node itself is a function. It is one of many built-in functions that come with Unreal Engine. So functions can, and often do, contain other functions. Also note that unlike custom functions you create yourself, you cannot easily view or modify the logic of the built-in functions. Okay, so the first part of my message is the word hello, followed by a comma and a space. So I'm going to hard code that into the append. Next is the person's name, which I can get from the input variable first name. So I will connect that pin to the B pin. And now there's one more part of the message, so I'm going to add one more input pin to this node. And in pin C, I'm going to type a period, followed by a space, followed by the sentence, "How are you today?" So now I have constructed my message, and I want to pass this message back out of the function. So I will take the return value of this node, which contains my combined string, and connect that to the pin of the return node, which contains the variable that this function will output. Okay, so now my function is complete. So first I'm going to compile it, and then I'm going to go back to the event graph for the level blueprint. And now I have the function here ready for me to use whenever I want. So I'm going to drag and drop this into the graph, and I'm going to connect it to the event begin play node. And now I'm going to create a print string node. And I'm going to connect the output of my welcome message function to the print string node so that whatever my function outputs gets printed to the screen. And now all that's left to do is give this function some input. So I'll just hard code in the name David as the input for this function. And now if I compile this and run the game, when the level begins, it will print the message, "Hello David, how are you today?" to the screen. And if I change the name I provide in the input, the output will change without me having to make any changes to the function itself. Alright, so that's how you create and use functions. But what's the point? After all, I could have just added my logic right here and not bothered with creating functions at all. Well, there are actually several reasons to use functions. The main advantage of functions is reusability. If I wanted to use this greeting dozens of times throughout my game with a bunch of different characters with different names, I don't want to have to write this logic every single time for each character every time it's used. I'd rather just write it once and be able to use it over and over again. Another advantage is editability, meaning it is much easier to make changes. For example, let's say I later decide I want the wording of this message to be slightly different. If I had this logic in dozens of places, without using a function, I would have to manually try and find each of those places and then edit each one individually. But with a function, I only need to make the change in one place, in the function itself. A third advantage of functions, unlike your reckless no-good brother-in-law Roger, is reliability. If you use a function that's already been used and thus tested over and over again, there's a much better chance that that function is free of mistakes than logic you just wrote. For example, many of the built-in functions in Unreal Engine have now been used repeatedly by numerous companies and developers, and thus any bugs they may have once contained have already been reported and fixed. And a fourth advantage of functions is readability. While this particular function I made is very small, functions could contain hundreds or even thousands of nodes. But no matter how many nodes a function contains, it will always get condensed down into just one node. So by hiding away the guts of your logic in this way, it makes it much easier to understand the logic of your game at a high level. Okay, so now I'm going to go back over to the details panel for the function and go over the remaining properties that are available to edit. So the first property is description. This is used to briefly explain what the function does. Whatever I type here will appear in the tooltip message that pops up whenever you hover over a function. So if you come back to this function later, or someone you're working with comes across it, this makes it much easier to quickly understand what a function does without having to open it up and analyze its logic. The next property is category. This is used to organize your custom-made functions. So for example, I could assign this function to a category called string, and then in the My Blueprint tab, it will group the function under that category, along with any other functions I assign to that category. The next property is keywords. This can be used to add a list of keywords to this function, which can be useful if you search for this function later. The next property is compact node title. So right now, when I call this function, the function node looks like this. But if I give this compact node title property a value, it will display the function node in a compact form with the value I entered being displayed in the background. Next is the access specifier property. This is used to specify what blueprints are allowed to call this function. With this set to public, any blueprint is allowed to call this function. With this set to private, only the blueprint that the function belongs to is allowed to call it. So for example, this function was created in the level blueprint. So if I set this to private, I will only be able to call this function from the level blueprint and no other. The protected setting is like the private setting, except that the function can also be called from blueprints derived from the owning blueprint. I'll talk more about derived blueprints in the section on players and input. Alright, so the next property deals with the concept of pure versus impure functions. A pure function cannot modify any of the variables of its blueprint, while an impure function can. This function doesn't change any of its blueprint's variables, so I can actually set this to pure. And by doing so, this will remove the execution pens from the calling node, leaving a much more simplified version of the node. And then the final property here is call in editor. So far we've just been looking at level blueprints. But as we'll see later on, every actor can have their own blueprint as well. So if this was a blueprint for an actor, and the call in editor property was checked, then I could click on an instance of that actor in the viewport, and in the details panel, there would be a button that I could press to run this function. Alright, and that will conclude the lecture on functions.